in Cosmos Hub, right, you have like a governance process, right? It's like, how strict is that? Oh, well, it's like a very rough consensus, insane thing. God bless the people who like spend their time in the Cosmos Hub forums, but we got Neutron and we got Stride through that, right? And like everyone else kind of can go look at those forum threads and be like, is that a good way to spend my life if I want to launch a chain?
The sequencer business is hard and complicated, so you might think Josh is a waiter at Olive Garden, but he's actually the founder and CEO of Astria. Astria is a shared sequencer and one of the first in the game. So we talk with Josh all about sequencing. That's shared sequencing, decentralized sequencing, and even lazy sequencing. This episode is jam-packed and technical, so let's get to it. There's these tweets about, I think Gwart has a really funny one that's like, I asked my grandma why there's a lack of mass adoption, and she says it's because of the lack of these centralized sequencers. And so it's funny because centralized sequencing isn't a head-on-fire problem, but it's also like not a problem. So I guess what scale is the shared sequencing problem at? At what level of severity?
Yeah, so I think it's like I'm gonna use the words wrong. It's like a Damoclean sword kind of thing, right? Like everyone's a little bit, and I don't want to like bugbear it excessively, but I think it's like worth mentioning because it was like influential in kind of like the origin of like why Astria is decentralized sequencing, shared sequencing, etc. There's this idea that like for better or worse, regulators are like bad. They're kind of like bad at their jobs of being regulators, and so we have this very like volatile like environment we're working in as like developers, project, whatever, where you say, okay, right, like I can get the centralized thing out. There's like a lot of simplicities to like that, but you're always kind of wondering like, okay, do you wake up and you have an email, you have a Wells note, you get a thing that says like it's got to be off, and maybe it's got to be off today, maybe it's got to be off by the end of the week. And this gap from going from like the centralized thing to like the decentralized thing that would be, able to allow you to kind of respond to that email by saying, I will turn off the boxes as a US entity or whatever entity is like within the jurisdiction. I will turn off all of my boxes and like wash my hands of it. And being able to respond like that and then still have the system function, I think, that is like a very non-trivial kind of step to go to. And so there's this sense of kind of like a pre-investment. And I think generally we should think about infrastructure a lot as this kind of, pre-investment. There's a lot of kind of analogies you could use to like various kind of historical, technological kind of developments, investments, whether through venture or otherwise. Where you say, well, it's not really solving like right now, but you're kind of assuming that like there is a risk of a problem later. And if we don't, kind of prepare now, then when it comes to a head, you're just going to be like down for like a long amount of time, right? And I think these like roll-ups, right, like from like a security perspective, they have like forced transaction inclusion, there's various like same parties kind of owning various things. But like, if Optimism has to like turn off the sequencer, right? Like we could chug along with like a non-US entity doing all the withdrawal transactions, and because it's ETH in there, it's not a native asset. The OP token would probably be in a bad place, but like everyone would be able to get like their ETH deposits out. I'm like generally confident that like you're not going to get stuck there, and that's kind of the point of the roll-ups. But like no one's going to continue using Optimism as like their daily driver if the interaction is now like submitting a transaction on L1 to then go, pull up and execute some state on L2. They're just going to do it as an off-ramp. So I think that's the like useful starting point of like why decentralized sequencing is like there's a need somewhere in the stack of the industry to kind of pre-invest in something to avoid some existential crisis coming up and then saying, oh shit, we're like down for like until we solve this technical challenge.
Okay, that's a nice just precursor. So you used to work at Celestia and then you moved on to building a sequencer. Like how did you transition into that? I think, did you get inspired by the lazy sequencing post?
So the lazy sequencing post by like Evan, I don't want to too much credit, like that was like a joint thing, and that was like myself and Jordan, my co-founder, and like Evan all at like a Celestia on site, talking about these things. And Evan was like, I think you have to do, the term that came out of it was like 2 chains. And so we'd been thinking about this for like a while. The origin of Astria goes all the way back to what was called Sevmos, and kind of the stuff I was working on, when I was at Celestia was, a mix of stuff, but like largely on, what was called Sevmos, using what is now Rollkit. At the time it was like Optimint, and then it became Rollmint, and then it became Rollkit, and working with like the Evmos team to have like Evmos or Ethermint as like a Cosmos app that plugs into what is now Rollkit. That would be what like Sevmos was. That was kind of like the origin of kind of Astria, and fundamentally like Rollkit, right, as it's like defined now, if you run like a Rollkit rollup, that is it's a sequencer. It has like a sequencer component to it. There's actually like a relatively clean kind of like code level abstraction within Rollkit of, are you like a block producing node, or are you like a syncing full node or whatever, right? And so a lot of my work at Celestia had always started at like sequencing, right? I was just building like sequencers in like Rollkit, as in like it is a rollup sequencer. And so the move to kind of Astria as like decentralized shared sequencers wasn't, I guess, like a move from like a structural kind of like, oh, I'm going to go to a different new category. It was just like taking a different approach. Essentially, we had spent enough time on kind of Rollkit and trying to build stuff with like Evmos as like an integration into that essentially when I brought on like my co-founder, and he joined in like October of 2022, and this is when like Astria as like a independent thing really kicked off and it started accelerating. We kind of made the hard decision to say, we think we're going to get something better that's going to be more expandable. It's going to give us a lot more kind of like necessary flexibility in the design space if we build it not completely from scratch, but like significantly more from scratch. So like our first implementation of like the Astria sequencing layer was using the kind of example proof of concept that Evan put together for Rollkit and Metro is what he called it, as like an implementation of this like lazy sequencer like forum post, right, he put out. And then we kind of decided in it would have been like April like 2023 at like a team on site when we had whatever like 7 or 8 people at that point. We were like, all right, do we commit to having Metro and building our foundation on Metro? Or do we say, fine, we're going to do our own thing. It's going to be a significantly larger amount of work, but we're going to build what we now term like the Astria stack, and we're going to build that ground up. And we did that. And like, there's trade-offs. Like fundamentally, we probably would have been live like 6 months like ago if we had not done that, because we had to build a significant amount of things kind of, from scratch. But based on the kind of experiences we've had and the experience we've seen other teams have, fundamentally, I do think that was like the correct decision, because now we have something where we know it works very well because we had to build it ourselves, and so we know kind of all the internal workings. So, yeah, I know that's like long-winded, right? But like, I think structurally we've always been building kind of the same thing, and the thing it's been on my mind. I don't want to like derail the conversation. Like, I think there's a little bit of a narrative trend happening in crypto where I have said this on a lot of different venues. Like, people keep rewording things to kind of describe it a different way, and I think it's given this impression that there's like a lot more levers in the kind of like topological like architectural design of the systems. There really aren't that many different designs at like a very high level broad scope. There's a lot of different names for things, but I think structurally there's like a relatively well constrained set of trade-offs that you're making in how you design your system.
Mm-hmm. Yeah, I didn't know that whatsoever. I guess let's now go through sort of the words, because there's shared sequencers, and then there's like decentralized shared sequencers, and then I guess let's start off with centralized sequencers. So if you could just like give us a quick rundown on like the whole deal. Some people even think that like centralized sequencers is like a good thing or like is an advantage, and you should like only you should have a centralized sequencer. If you could just go down the list of words of like what a centralized sequencer is, a shared sequencer, and then a decentralized shared sequencer as well.
Yeah. So there's like two like axes or whatever, right? If you want to define a matrix, right? You can have like a, I don't know what you call it, like independent sequencer or whatever, right? Like it's a sequencer that is running for like one roll-up state machine, whatever, right? Or you can have a shared sequencer, which is presumably like some entity doing sequencing for like multiple roll-ups, and then you can have, right, a decentralized versus centralized, right? And so like right now we primarily run like a centralized independent sequencer. That's what you're gonna get out of your OP stack, out of your various like RAS services, right? Arbitrum's gonna run this. And I think it's useful, this is not novel, like the docs of like all of the roll-up frameworks will like explain this, like, to separate, there is like strictly like two things. There is like an act of sequencing, and there is an act of, I guess I'd say like validating the bridge. And this is kind of what I mean when I say like there's not that many like variables in the design space here, right? The sequencer fundamentally is essentially like, if you're coming for like a Cosmos space, it's like, it is structurally very, very similar to like a one node Comet BFT chain. Like you can go run like, and we do for like DevNets, like this is like a common case doing DevNet local development testing. You run a single Comet BFT node and your Genesis says, yeah, all the stake is owned by this one node. That's the only guy who can produce blocks. That is structurally very similar to like what a single sequencer is. It's just going to be one node. It comes to consensus with itself, right? Like it doesn't have a consensus done. It's just one node that says I produce a block. I know that block is correct. That's my block. And then it executes the kind of state machine. And so users kind of submit directly to that, right? And really like, again, from like being very similar to Comet BFT, if that's your familiarity, you can have the sequencing node. You can have a full node that also submits to the sequencer. The sequencer is going to have some block production loop. The way in which it constructs those blocks could be, various things. I think Dan Robinson and Dave White from Paradigm had a good post on kind of like priority fees and like thinking about structuring. We have things about FIFO. We have things about, fair ordering. We have things about priority fee gas. But fundamentally, you're just going to have one node that's responsible for producing the block. That is always responsible for producing block. Ben Fish at Espresso uses the term that I think is great. It's saying there is a single entity which has a persistent monopoly on block production. And the distinction there is that in like a normal leader-based consensus protocol, for any given block, slot, height, whatever, there is the leader that is going to have the monopoly on the ordering and the inclusion of transaction in that given block. But then if that entity is censoring, certain people or whatever, the next slot will presumably have a different leader and they will presumably not be censoring the same way. This is where we get into collusion. For a centralized sequencer, you're one person doing it, they persistently get to do it, right? Block over block over block over block, right? So that's like a centralized sequencer. And again, the independent aspect of that, they're just running one state machine. If we go to like a shared sequencer, and I think it's like useful to explain like why we are building a shared sequencer and why we are building a lazy shared sequencer fundamentally came out of a desire to provide decentralized sequencing. But then the practical kind of economic limitation of what is required to do decentralized sequencing. And so I'll loop this back, when I get through it, like to like why people think centralized sequencers is good and why there's some legitimate argument for like centralized sequencers, I think, is decentralized sequencing, like we'll take decentralization as a very simplistic, statement, right? We can say like Nakamoto coefficient, whatever, right? But fundamentally, there are going to be more than one nodes in the network, right? And presumably, when we think about decentralized sequencing in the world context, it is multiple nodes that are allowed to produce blocks, right? So that you have a set of entities that share the responsibility of having the monopoly on the inclusion and ordering of transactions in a block over some kind of like time period, right? Whether it's block by block, whether it's every 4 block, you have things like Solana, right? Where a leader has like 4 slots in a row, right? So something like that, right? We go to decentralized. The difficulty here is that you have to have more nodes running, right? Like if I run one node, I have one node, right? If I have 10 nodes in like my sequencer set, okay, my costs at some very first principles level are like 10 times higher, right? And it's not absolute, right? We assume like centralized sequencers are running like fallbacks and, we have like DVT style things, or we have like just running Raft across multiple nodes and like, one, whether it's like one cloud location or on-prem or whatever, but like roughly, right? If you have 10 nodes in your leader set, you have 10 times more just like straight hardware costs, right? Especially if we're paying kind of the fixed cost of just like being a person, right? Whether it's like employee costs or like setting up a data center or whatever, right? So you're gonna have a higher cost. And what we looked at is, again, around this like October 2022 timeframe, we talked to a lot of kind of like Cosmos, Comet BFT like validator entities, and the market was down, right? This is like everything is collapsing, right? And so a lot of the Cosmos guys are looking, they're saying, look, I'm validating whatever, 50 chains or 75 chains for the log or org, and they're saying, I'm not making money on like 60 of those or whatever, right? It might have been more, right? They're like, this is not profitable, even after whatever, 150% APY, like inflationary token issuance. There's like, I'm trying to sell those at a market price, whatever. They're like, it's just not worth it, right? Like I'm not making money on my operational costs there. And so our view was, okay, you take this roll-up thesis, however many you think there's going to be, whether it's going to be 10, 100,000, 10,000, whatever. The general thesis is that you're going to have more roll-ups than you are going to have chains that each have their independent kind of validator, committee, whatever, right? If you believe that, then if you want to have decentralized sequencing, you can't say that each of these chains needs to have their own decentralized set, because we've already seen in kind of economic downtimes, validators starting to trim the long tail of the chains they're supporting. If we increase the number of chains, we assume we're just going to have like an even longer tail of chains, right? So shared sequencing and lazy sequencing coming out of that was this design where we're saying, how can we provide the ability to have decentralized sequencing for many chains without each of them having to pay this cost of having their own set? And really, again, kind of going back to like, discussions like we had with like Evan Forbes and the rest of the Celestia team, a lot of this comes out of the Cosmos Comet BFT Tendermint kind of world, where if you're like familiar at like a technical level with like Comet BFT is like not like coming to consensus over like execution. Like it is in like an abstract, but like generally like Comet BFT doesn't have an awareness of like the state machine that is talking over. Over ABCI, it's just gonna say, here's the transaction. What's that transaction? It's bytes to me. I don't even give a shit. Like that's Cosmos' job, right? To figure out what to do with those bytes. There's some issues with this, but fundamentally there is already this idea over ABCI of a separation between consensus over bytes and data within a network and execution of said data, right? So you get like the app hash and you get a consensus over the app hash and whatever. But that was kind of the origin of how we looked at this, where we said, you know, there is like, okay, how can we just have that, but as like an independent kind of like network, right? Of like, I just want the data part. So to some degree, you can think about Astria, a very, very broad simplification here, as it's like Comet BFT as a service. Like we're gonna run one Comet BFT cluster, and then other entities are able to use it through well-defined APIs for how to integrate their state machine into it, and that's how they use it. And so, I know it's been like long-winded and I've kind of gone, we'll pause there, but happy to dive into kind of trade-offs with like centralized sequencers and some of the benefits and some of the fundamental like costs or kind of problems with like lazy sequencing as like a structure.
I think we should get into, that was good. I think we should get into like what is lazy sequencing first of all, and how like you guys don't execute the transactions. So what is lazy sequencing? And if you guys don't execute the transactions, how do you guys know if they're even like valid or it's supposed to be in the block or yeah.
And so I'll try to like, there's like a lot of like tangents we can go off here at lazy sequencing. Like fundamentally lazy sequencing, again, kind of came out of this view on the Comet BFT versus Cosmos SDK. Anyone who's like operating like a Comet BFT chain, especially in like the, you know, the Rollup space or whatever, like the, you know, a lot of people are familiar with like, just like nonce as an issue is like, what are the difficulties with Comet BFT? And I swear I'll like connect this. Is like the nonce management is done on the Comet BFT side. However, Comet BFT is not aware of the transaction typing. And so if you submit like two transactions in a given block, Comet BFT will be like, I don't know, like, you know, I just see two transactions. I don't know which of these is like better because like it doesn't have like a concept in like the app land of like which of those transactions say is like paying a higher fee or things like that, right? So you have like a separation of like app side where it's like, here is the state DB, here is like the logic of my application, whereas Comet BFT is just like, I just have transactions and I just know a transaction, you know, for XYZ, whatever, right? So there's kind of like a separation there, right? When we think about lazy sequencing, it's structurally kind of very similar and we face a lot of those like same issues, right? And so it's this idea that like the sequencer itself has an app, right? So like our full Astria as a chain has like an app, but it's very minimal like state machine that we have, right? It's not Cosmos SDK, it's like our own state machine we've built. You know, thank you to the Penumbra folks who did a lot of great work with Tower ABCI and Snidarium, and we borrow both of those frameworks as well as like their fork of like IBCRS. You know, we build on top of that stuff. But the state machine is essentially, you know, very minimal in that like what a transaction to like our sequencer looks like is like, we call it like a sequence action. That's like the naming framework we use, but it's essentially a vector of bytes, where a vector of bytes is essentially a transaction, right? You know, it's like n bytes, right? We assume that that is like a serialized, encoded, whatever transaction from any given state machine, right? For example, like an EVM, it could be a move VM, it could be a Cosmos SDK application, right? But there is some transaction that was serialized and submitted to our chain just as serialized bytes. And so what our chain actually comes to consensus over with Comet BFT is just saying there is a bunch of transactions that are all these sequence actions, they're just like bytes. And we just include them in, right now, like a naive like FIFO order, right? They reap max transactions, max bytes in like Comet BFT land, we produce a block and then we spit that out, right? From the rollup case, right? So there's a question of like, who executes these, right? Or like, we don't execute, how do we know if they're correct, right? We fundamentally, that is not the job of like the sequencer in the space. Its job is not to know if the transactions are correct according to the state machine rules of any given rollup. And the reason for that is that the alternative to lazy sequencing, right, what has been called like shared validity sequencing, you know, is the idea that you have one set of operators, right, entities, validator set, whatever, and they are going to have to execute the state machine of every single rollup running on that sequencer network, right? And so what that means is that adding a new rollup to that network is a non-trivial cost to the existing operator set. And so on the margin, you would assume that that operator set has to have some permissioning mechanism to prevent anyone from just adding any given state machine to that, right? And what that means is that in existing kind of like shared security designs, right, that do the kind of execution themselves, most notably like Polkadot and Cosmos hubs, replicated security or interchain security, whichever you want to call it, there is like a strict process to join the network, right? In Cosmos Hub, right, you have like a governance process, right? It's like, how strict is that? Well, it's like a very rough consensus, insane thing. God bless the people who like spend their time in the Cosmos Hub forums, but we got Neutron and we got Stride through that, right? And like everyone else kind of can go look at those forum threads and be like, is that a good way to spend my life if I want to launch a chain? And then the alternative in Polkadot land, right? And again, I'm going to be like, abstracting here, right? I'm not an expert on like the low level of like Polkadot, but the initial parachain auctions were like, call it like $55 million to like win the first one, right? And there were only 10. And so you had to have this whole capital, right? And so our view is like, okay, if you have the time, effort, energy, political, social clout to go win an argument on like the Cosmos Hub forum to get accepted, right? Neutron and Stride were like known players in the ecosystem, then like fine. If you can raise $55 million of like capital in DOT to win a parachain auction, right? Like, okay, fine, but like we don't want that to be like the blocking factor to like have like a decentralized roll-up, right? If you can do those, you clearly have the resources, the competency, the expertise, whatever, to go stand up your own validator set. Like that's much cheaper than like getting 55 million of DOT, right? That's much lower effort than like winning an argument on the Cosmos Hub forum. These are like things. So the lazy sequencing thing is on the assumption of you can add any number of chains to this because the sequencer does not know about the kind of contents of any given transaction. It just says, that is bytes to me, all the bytes are the same. There's like a roll-up ID associated with it, obviously, but it doesn't change what the work that the operator set has to do. So that's like fundamentally like what lazy sequencing is, like why.
Okay, so you have these like lazy sequencers. Obviously, you guys are not executing all these things because whenever there's like a new roll-up framework, you're going to have to like download all their binaries and you're going to have multiple different versions of Optimism and all their forks, and like, another Optimism forks comes online. You have to like run their binary. Like that's not scalable whatsoever. So you just sequence them, just order them up. And then what happens after that? I'm still a bit confused. They're all sequenced, they're all in order. It doesn't understand if they're valid or not valid. And then where do these sequence transactions go necessarily? Because I'm thinking you have all these transactions, they're sequenced, but how do you know if they're correct? Do you send these? I don't know. Yeah.
Yeah. So you still need like a roll-up full node, I guess. That's like the core kind of like thing, right? It's like you need like a roll-up full node. And what this full node is going to do, right, is it's going to read the subset of transactions off of the sequencer. And the design we have and the kind of component and tooling we provide out of the box, it also has the ability to like seamlessly read from like Celestia as a data availability layer. But it essentially connects to, very similar in a way to like, Optimism's like OP node code base. But it is just a full node, and EVM rollup would be like a Geth node, right? That's like lightly modified to work with our like APIs, and it's going to read and ingest the blocks out of the sequencer, and then it's going to execute those, and it's going to come to it's not going to like it will like if you run multiple full nodes, right, in the same software stack that read the same stream of data, they will come to like the same state root, right? And so it's like running a full node here, right? And the Celestia people have called this like a pessimistic rollup here, right? Where the only way to get like a legitimate understanding of like what the valid state is to like run a full node of it, right? There's not any kind of like trust minimized light client via like validity proofs or fraud proofs. But you do still need this full node. And kind of extending that into like kind of why we were like okay with that, I guess, it is like two things. Like one, just like the fraud proofs aren't here yet. They're very close, it seems. But they're like not here yet. They're not like off the shelf, right? Like, there are various arbitrum people who are mad at people. Like Bold is like not like live on mainnet in like an unpermissioned like fashion, right? Which naively gives me the assumption there is some kind of like long tail risk there, just like, whittling down, which is fine. It's important, right? Like, security. And the ZK VMs or the ZK EVMs are also like not quite here from like a permission list to like launch a thing like naively, right? And so the reality is like if you're thinking about the entities who are like running nodes and like users who are interacting with, like one, for better or worse, users don't run nodes. That is like an ongoing like challenge, like Celestia with like light nodes doing that, but users don't run nodes. So the gap between them running a full node and light node. Exchanges are going to run full nodes, right? Like an exchange is like, going to like wait for like the finality window, but it's going to run a full node. It's not like waiting on like a challenge game. It's just like, we are like a sophisticated entity, we run a full node. So you do have to run the full node. And then the other thing is like connecting it to like the RAS. So like back in December, we launched our own like Rollup as a service as kind of like a quick experiment thing to kind of see what the kind of demand was for that. Because again, going back to like users don't run nodes, right? We had a bunch of docs on like, here's how you can run a node yourself, here's how you can do it in Kubernetes, whatever, what's required to do that, like a 5-minute walkthrough tutorial, whatever, like no one did it, right? Like these people want a button. So we made the thing, click a button, you get a Rollup node, right? But the core distinction between what our Rollup as a service did versus, a Conduit or a Caldera or like a Gelato or whatever, we weren't running sequencing nodes. Fundamentally, we were just running a full node that was a new Rollup, right? And it had its own chain ID and it had its own state machine, right? And its own state database. And it submitted transactions to the sequencer and then only pulled out its subset of transactions out of the sequencer. But like, if you turned off that full node, right? It's not like the Rollup stopped. Like someone else might be running a full node and continuing to submit transactions to the shared sequencer and read those and execute those blocks. If you turn on your full node again, it'll just come to sync, right? It was not actually responsible for like the liveness of the block production of the network, right? But fundamentally, you still need this full node. And the other point I want to make sure we kind of cover here, right? Because I think it's important for people to understand like this like limitation with like lazy sequencing, right? And like the things it's not getting out. There's been this big kind of discussion for like years now of like, is a Rollup about the bridge, right? Like, is a Rollup about the fact that, like, the data is written somewhere else and can be deterministically read off of that? Or is it about the bridge? And we're not going to, like, answer that question, but I think fundamentally I would say my assumption of how little it was about the bridge was wrong. Like, I was off by a little bit on how important the bridge is, right? Because fundamentally the thing the bridge gives from, like, a user experience developer kind of, like, advantage, right? You're a person, you want to build your own chain, right? What do you want? Well, you need to have people be able to onboard to your chain. And I think a lot of people underestimated and maybe continue to underestimate the importance of a new user being able to easily access your new chain. And so I think this is one of the reasons that, the rollups on ETH all use like ETH as like a gas token, right? Is because they don't have to establish their own token. They don't have to get that token listed on a centralized exchange or whatever, right? Fundamentally, the bridge is what allows a user who already has ETH or who has, fiat through a centralized exchange, you can buy ETH on any exchange, right? To onboard that to the rollup through that kind of well-defined bridge. One of the things that the shared sequencer does not do, kind of like plainly, right? It's not executing the state of like any given rollup unless it's not providing this kind of, this attestation of the legitimacy or the like validity of a given state root at a given block height, which is what is necessary for like these roll-up bridges, right? And so if we look at like Forma, which is like running on top of like Astria stack, it's not running, I can go into Forma if you want to talk about that more, but like it fundamentally has its own bridge powered by Hyperlane and Stride. And so the TIA is bridged from Celestia over IBC to Stride's chain, and then from Stride using Hyperlane to bridge over to the Forma EVM. And so, again, the shared sequencer right now, and like we're working on a native bridge implementation, but does not naively provide a bridge because it is not executing. And I think that's like a fundamental limitation of the architecture. If we wanted to execute all these rollups, right, and say our validator operator set is going to also execute the state machines of the rollup, we've now significantly constrained the flexibility of kind of development, but a little bit of the alternative is to kind of punt it as like an exercise to the reader to say, hey, you want to go, run a bridge, you got to go figure out a validator. And if we look at the rollup of the services right now, by and large, it's just kind of like a centralized bridge right now, right? We look at like how the Optimism bridge works on, for example, like, the L2 Beat guys had a good thread on Conduit. They have like one multi-sig that is utilized for like the bridge kind of contract ownership for like whatever, it was like 5 to 7 or whatever, like Conduit chains. And I'm not, that's like criticism of Conduit. I'm like, that is like absolutely the correct, sane way to do that. Like any alternative Conduit does where they're like, well, actually we as Conduit maintain 10 different multi-sigs for like 10 different chains, but they still hold like the keys, or they still have the same thing, like duplicative work that like doesn't actually provide an additional security benefit. But it's something to keep in mind is like, fundamentally, like one of the things when creating a large number of rollups is in the absence of, validity proofs or like, fraud proofs in like a permissionless manner, we're all kind of going to be in the business of like going and getting someone to like, help us run a multi-sig or running like a centralized bridge right now. And that's just like a known kind of thing you have to go buy off the market right now.
Mm-hmm. So you guys have I guess there still is a centralized sequencer. It's just not doing any sequencing. And so the full node it's like I guess like an executioner. Like it's just like the node that executes the transactions. Is that, what is a good word for these?
Yeah, and I guess when we say like, when we say centralized, I think it's like a question of like, I would say like, and this is going to be like slightly like too like researcher infra brain to be like maybe useful to like a layman, but there's like fundamentally we accepted and decided that it was like a useful separation to separate the act of sequencing from the act of bridging. We were like, those are like useful components to be like at some like somewhat technical abstraction, like useful. It's like you run a full node of the sequencer, right? You just run a full node. It's like, is it like centralized? Well, you can go run a full node however you want, right? Like it is like you can run it locally. We have good tooling. We'll have a blog post up when I get to writing blog posts on, we have local development tooling for running a rollup. But you can run a rollup locally. That's like using our tooling. We have like a terminal UI for this. You can run it in like Kubernetes cluster. You can just pull the binaries and run that on a Mac or a Linux or whatever. And you can like run that full node, right? And it just has to come to sync, right? And then, we can get into like whatever weak subjectivities, sync, snapshot, whatever. But like anyone can run a full node, right? And so our view is that like, if you're going to be paying an entity to run a node on your behalf, ideally that node should be outside of the block production path. I guess what do I say? Like if you want to do validation yourself, I think it's legitimate to say, I'm gonna go pay Alchemy or whoever, right, to go run a full node. And it's gonna be like my full node is run on their servers, whatever, and then I have my own RPC node, and it's just sourcing its data from, the DA layer and the shared sequencer. And this node is not responsible for producing blocks, but I can ping it and it'll submit blocks to the sequencing layer on my behalf, right? That feels like a good model. We just don't want like it to be in the, if my node goes down, then like the whole network goes down. No, there's going to be other nodes in the network. But the bigger point is, again, in the separation of sequencing and bridging, fundamentally the bridge on kind of wherever the DA layer. So for example, on Forma, the bridge that it is kind of making a trust assumption with is with like Stride. So like if you withdraw your TIA off of Forma, you withdraw it to Stride. And I'm not sure where like the front ends and the routers have gotten to, if that's like a one-click thing, if you can like hop from that using like IDC hooks or whatever, but you withdraw it to like Stride, right? And so that's where your kind of like withdrawal is gonna go. To withdraw, someone has to make an attestation of the legitimacy of a withdrawal event from the rollup to unlock funds on Stride. And that is something the sequencer is not providing. That is something that you need this external validator set, multi-sig set, whatever, to make an attestation to, right? That is the thing that like we as like Astria are like not doing, and that we are providing designs for bridging that would be integrated into the sequencing layer, but explicitly we have like a design to say like, well, here is what like a bridge lock looks like, and here is how that deposit event would be derived into the rollup state machine. But the withdrawal path is this like exercise left to the reader where you have to figure out who is the entity, set of entities, collective, committee, multi-sig, whatever you want to call it, that you're comfortable with accepting as like authorizing a withdrawal event. And that is like fundamentally something that can be separated from the block production and the sequencing act. But then again, kind of looping it back on the discussion with sovereign rollups and like, we call them like governance rollups way back, or like, these bridge defined rollups. It's a question of like, what is the utility of a rollup without a bridge? There's definitely some, right? Sovereign rollups that just run on their own, native coin. How do they get the coin? Whatever. That's definitely an interesting space that I think hasn't been explored yet, and we're interested in that. But I think right now, a lot of people are getting the utility out of the bridge. And that's what same with like L3s, right? Again, the people are getting value out of the bridge on the L2, and most notably, I think on why L3s are valuable. There's a great thread by one of the Arbitrum founders on like why L3s are useful. It's a very practical, real world, end user experience reality. I am a new user. I want to launch my like L3, right? And I want to get new users that are not crypto users, right? Maybe I'm launching some whatever, app chain, social, whatever. I want to get people that have fiat. They want to on-ramp to my rollup. If they have fiat on Coinbase or whatever, and they want to withdraw it all the way in my L3, what they have to do is they have to do Coinbase and withdraw to either Arbitrum or Optimism or Base, which all being large enough have native centralized exchange integration. So you can onboard right to the L2 without going through the L1, then you go to the L3. Well, the deposit transaction on the L2 is going to be on the order of whatever, a couple cents, right? If you go from the L1, it might be on the order of a couple dollars. And so again, the bridges need to be viewed a little bit as this user experience on-ramping thing. And I think that is like a not spoken enough kind of point of like what we're doing with the rollups. It's like the ability to onboard to a new chain without having to go bootstrap that somewhere else.
Mm-hmm. I guess let's now talk about like how to create a shared sequencer. Do all of them just use Comet BFT? Is there any other consensus protocols being used for these sequencers, or it's all just Comet BFT for all of them?
So the only shared sequencers I'm going to be like, I'm only familiar with the designs of our own at a high level, espressos, and that's about it. Like, I don't know what the other people are doing for like their kind of like, sequencing, like structuring, whatever. Most notably, like, we are using Comet BFT. Espresso is not using Comet BFT. So Espresso spends a lot of time and effort working on, Hotshot, which is like a slight modification on top of Hot Stuff. More strictly, like, they have implemented, as I understand it, the changes from Hot Stuff 2, which like reduces a hop and like the practical Byzantine fault tolerant like consensus algorithm. So they don't use Comet BFT. They use like Hotshot, and Hotshot is their own kind of espresso thing. I'm not going to go into like details of like how we've built ours, but I'm not going to be able to comment on like anyone else's beyond like espressos, and it's been a while, and I don't have time, unfortunately, to read through kind of their docs and architecture.
Mm-hmm. Okay, and then how much sequencers are going to be part of the like shared sequencer network? I'm not asking about Astria specifically, but like if one was able to run on like a centralized sequencer, then like, do you think this is the number of like 12, or is this going to be more closer to like 100, 200? Like, how much shared sequencers do you think are going to be inside the network?
So, a lot of that's going to be, again, dependent on the kind of like consensus algorithm, right? So we're running like Comet BFT. Generally, it's known that Comet BFT doesn't scale that well with like large sets of like entities in the committee. I think Cosmos Hub is running like the largest like set at like 180, I think, like active validators in the set. We are tentatively planning to go to our like test net here with like 10. We might go to mainnet with like 10. What the upper limit is going to be is really going to be a trade-off on kind of, Comet BFT, so your consensus algorithm, right? If it's like a PBFT algorithm with like, single slot finality, then just like fundamentally everyone in the active set has to vote in the block, or at least 2/3 of them have to vote, which means you assume you have to get, the transaction propagated to those people. So you have latency, hops, right, PBFT, right? And so you just gonna have limitations there. My understanding is that like Hotshot and Hot Stuff are like much better at this and can support much larger numbers of nodes. I know the Espresso guy's recent testnet is running 100 nodes, though it's 100 nodes across 10 operators. So, I think the big thing we think about is like, what are we trying to gain here? And so a little bit of our thing is like, right now you're going from like, there's one node in the set, right? And you want to go to like more than one. And then there's a question of like, well, how many is the correct kind of number of nodes, right? We get into like, what is like valuable decentralization, right? And so you'll have the Ethereum people say there's like, we have 500,000 validators. And like, that's like a psyop, like 500,000 validators just because they, for whatever reason, decided to define a 32 ETH like unit of stake as a validator, as no strict association with like a box. It's just like a minimum divisible unit. But you go look at like there's like a good Dune dashboard on like ETH POS, right? It's 29% or something this morning, I think it was. It's like Lido, and then like another like whatever, like 12% or something. It's like Coinbase. So like whatever, like 40% of your network is like Lido and Coinbase, right? So that you can halt it with like Lido and Coinbase thing. If we go look at the Cosmos chains, none of the Cosmos chains, to my knowledge, are going to have like greater than like 10 entities required to have like if you want 33% of like the stake weight, you're going to be able to do that in like under 10 actors on like any given chain. So generally how we think about this is we're like, all right, like what are we actually trying to like get out of here? And then if we look at Ethereum again, right, there's like 5 relays on Ethereum, so 95% of the blocks go through Mevboost. There's like 5 relays, and there's like 3 builders. And we're like, it's not 3 builders. Like, there's 3 relevant builders. You have Arsync, you have Beaver, you have Titan. So there's already a lot of points of centralization in the system. And so a lot of our view is kind of saying, we want to move from centralized sequencers to decentralized sequencers. It is going to provide, like, it's going to be a more difficult task. It's potentially going to have like a poor user developer experience. It's going to cost more money, right? Running more nodes, having more actors costs more money. That's one of the benefits of centralized sequencer, right? You don't have to pay for like yourself, whatever. You collect all the revenue, you don't have to share with like node operators. So we're trying to say like, okay, if we go to like 100, what gain did we actually get in what metric over having 10? Probably not really in a practical one. I think John Charbonneau's done a lot of good writing, last year on like proof of governance and proof of authority, and this is related to like Lido. Lido has like 30 nodes in their set, right? It's like, yeah, Lido owns like whatever 29% of the ETH stake, but that's like 30 node operators, but they're all picked by Lido, right? And there's a Lido governance process and whatever, but like it's an even split among those 30. It's not like a proof of stake split, right? And so this gets into kind of like ideological questions around like, what are you actually trying to get out of your decentralization? We're biasing more towards like a smaller set, because there are advantages to removing the persistent monopoly on block proposing, right? Where you say, oh, well, there's at least like 2 guys, like good. In like a lot of like like large kind of standard kind of company stuff, for a given industry, there might be 2 to 3 players. Generally, the fourth is going to be like irrelevant, and the third is often very, very middling. And you see this in a lot of, right? You have Coke, Pepsi. Who the hell's the third biggest like soft drink entity, right? No one knows, right? People will argue over who even the third largest is, but they're certainly not relevant, right? We look at like, okay, you have cloud providers, right? You have like Amazon, you have Microsoft, you have Google Cloud, you have Oracle. Oracle's pretty middling. No one really cares about Oracle. I guess you have IBM. They're also pretty middling. So like 4 or 5, irrelevant. Google's a pretty middling third. I worked at Google Cloud for like 5 years. Like, big fan of Google Cloud, but like they've always the middling third. They're self-aware of it. They're like 10% or something in the market share. Amazon's the dominant one. Microsoft's number 2, right? So when we think about this kind of like, what do you need to have competition? You don't need that many, right? And for decentralization, we want to go farther, but we don't want to have like a limiting factor on, oh, we tried to get 150 nodes to run. Now it's extremely expensive to run our chain. The thing is unsustainable and has like whatever, like poor economic structure because it's too expensive just to run a given transaction as like a base cost. So yeah, that's kind of how we think about it. Again, we're going to be upper bound limited by like Comet BFT in a way that I think the Espresso guys are not going to be limited, as my understanding of like Hotshot. But again, it's just like, what are you practically kind of gaining here? Like, are you actually increasing your Nakamoto coefficient by having a larger number of nodes? And it's also going to relate to how are you assigning the slot thing right now, right? We're going to go live with like a proof of authority, call it proof of governance, whatever, right? We're going to say, there's like these 10 nodes and you each get, 1/10 of the slots, it's not going to be like a stake weighted thing.
Yeah, I think 12 is like a good number. I think you said 10. Another question is that how do you dictate who joins this ordering committee, I guess?
Yeah, so very explicitly, we're going to be like proof of authority, right? And that's like, who's going to decide? Like, I'm going to decide. The network's not going to be like decentralized in any like truly like resilient manner at launch, because that would be like a nigh impossible task to actually like decentralize it, right? Like that immediately, right? There is a necessity to kind of do the like, okay, other entities come in and get involved. But largely going to us, it's my view, I've talked to a bunch of people kind of, up and down the kind of like industry, people who are, close to like, working at Lido, close to Lido, think about how does Lido pick their 30, right? How does, Eigenlayer pick like what operators, want to be distributed? Is that maybe more of a market-driven one, right? Does that approach like proof of stake where you see kind of consolidation? Do we look at, at the level above that, right? How do people pick that Lido is the block producer in Ethereum? Well, that's like driven by like an economics of like people give their funds to like Lido for like Lido ETH more than they give to Coinbase via depositing, whether it's via like Coinbase's interface or whatever, right? And so there's a question of kind of like how you pick it. We're just gonna be proof of authority, right? And like how are you gonna pick? Well, we have like 10 entities that we've like chosen for like our test net, and it's fundamentally it's like a reputational game, right? It is who do you think is going to be like a good actor in your system, who has a good reputation, and I think operator selection generally is like an unsolved problem in this industry. It's really like very much like a social game. You go talk to a validator, you have a known good working relationship. You ask them who their friends are, who their colleagues are, who they trust, who they have a good experience. You talk to all the other chains and say, who have you had a good experience in your ecosystem, right? What are the validators that offer you kind of the benefits, right? There's your larger institutional players, right? There's some benefit to institutional players, right? Maybe they're going to be less responsive, they're going to have more duties, but to some degree from like a security perspective, like a large, like well-known regulated entity is not going to intentionally kind of try to rug a protocol, right? And so there's some benefits there, right? Because they have more to lose in their aggregate business than they have individually on your chain. So again, we picked a set, we talked to a bunch of validators, we had a forum, way back, and we've had a lot of interest, right? Quite frankly, there's a lot of people interested in running nodes because they see it as very like lucrative, kind of like profitable business. But it's just like an unsolved problem, I think, operator selection. It's really just trying like a best thing. If someone like listens to this and like, I am the person that has like a great answer to like operator selection, by all means, but everyone I've talked to is like, yeah, it's hard. It's hard to evaluate the quality of like a node operator.
Mm-hmm. And so that's another thing is that like, if you don't really need large sets, can't you just like use Comet BFT for like everything? Like I know Celestia uses it and I'm like okay with it. I'm not like stressed out because there's not like a million full nodes or million validators. Another question is if there's for the market, there's going to be like shared sequencers, but do you think there's a point whenever sort of protocols or rollups want to have their own shared sequencer network? Is there sort of a turning point where like, you know, you have a smart contract and then you're like, I want to build my own app chain? Is the future going to be like, you know, I have my rollup, I'm using a shared sequencer, but I want to use my own sequencer set? Is that sort of a thing that rollups would want to do even?
Yeah, I mean that's just like market structure. I think to some degree, it's a weird thing to say, but like I feel like there is not enough MBAs, or at least there's not enough good MBA like sell side analyst style people in crypto to like evaluate just like market structures. There's some very significant predictive power of like what people are going to do just based on like, you know, what is like a sane market structure. You know, the saying in business, like there's only bundling and unbundling, right? To some degree, to say like, okay, I will be a person, I will like develop my app, right? And I will put my app on a chain, right? That is a form of unbundling. The chain will do the infrastructure side, the app will do the app side, right? And then eventually the app is like, I am either like feel like I'm paying too much kind of downstream in my supply chain. I bet I can vertically integrate that and run my own app chain. I'm going to have some presumably higher fixed cost, right? Whether it's like development, you know, whether it's like maintenance, whether it's just complexity, right? They're going to have to like maintain that network, whether it's user friction, right? Again, this is like when we talk about like fragmented liquidity and whatnot, right? That's like a form of user friction, but someone's going to take the bet, right? And I think people say like, oh, where is this going to settle? Like how many shared sequences are going to be? Like, I don't know. Like it would be like unsurprising to me if every like large rollup framework did not attempt to have their form of like a shared sequencer. And again, what a shared sequencer is, we've been starting calling it like a sequencing layer. The Espresso guy that started calling it like a marketplace for sequencing, right? We've seen, you know, Astria started calling itself like a settlement layer. Like everyone like hates the word settlement layer, it seems. We now have like the ag layer, right? Connext recently rebranded to Everclear and is calling itself like a clearing layer. All of these things are fundamentally an intermediary layer that is not your final finality thing, right? You abuse that term. So I think from like a market structure, I would be unsurprised to see Optimism try to have their own shared sequencer. Arbitrum, Starkware has like 2 shared sequencers. Like Madara is the most notable one, but they're like working on like a variety of like shared sequencer things, you know, within the Starkware ecosystem. ZK Sync probably tries to do one. Those 4 at least would like not surprise me at all if they all tried to kind of have their own shared sequencer. You know, obviously there's like Espresso and there's like ourselves, there's like Astria, there's Radius, right? You have Roam as like an attempt to implement a shared sequencer via Solana, which sounds like, yeah, there's no like technical reason that won't work. You can glue a bunch of components together and use Solana as the middle bit that gives you like this kind of consensus. So I think you'll see that, right? I think the big thing again to this like market structure, if you go look at just like companies, projects, kind of like financial kind of things work, like some of these are gonna like not work. And like some of the companies are probably gonna like die from like we had a good position as like an app and we're like, maybe we can like 10x our size, our TAM or whatever, whether it's, you know, an individual, you know, the leader of that project, whatever, whether it's like an investor desire. And a lot of these people are gonna fumble it. Some of them are probably gonna succeed. But like a lot of people are probably gonna like fumble it, like the app to like app chain transition, right? Maybe they try to go from like the rollup to like the rollup framework to like the shared sequencer transition. But that's fine. It's just like, you know, I think one of the difficulties in crypto is like things don't die. Things like more of the things should die, you know, like more quickly, and like that capital should return to like the broader market and get redistributed to someone else who didn't die. But I don't have like a good thesis on like, you know, which of these will win, which of these will take it. But again, like we kind of very intentionally built out our own kind of like Astria stack because we didn't want to be constrained by any given thing. We didn't want to build a shared sequencer that out of the box worked with like Optimism, because then we're constrained by the design choices that Optimism made, right? And I'm not saying they made the wrong choices. I'm just saying like they made an opinionated choice based on what they were trying to do in the market. We're doing the same thing, but we might have a different opinion. And so we want to be unconstrained. I think each entity that has like a kind of like opinionated view on like how they think, you know, the market, whether that's, you know, we want one big roll up, we want a couple big roll ups, we want them to integrate at the super chain level, we want to integrate the framework level, we want a shared sequencer, you know, however they choose to do that, I think that's kind of like roughly the level of experiments you'll see. From like a carrying capacity, again, I think we're going to see like, you know, we're not going to see 20 shared sequencers. I don't think we're going to see 20 roll-up frameworks. I don't know if we're going to see 5. We might see like 3. So I think we're just going to have to see the experiment. And there's another thing of like, it's kind of continuing my right, like in market structure, a lot of the like driving fact of like market structure and like crypto, people are like, why are there all these things doing the same thing? It's just based on like capital, right? Like you are an investor. You think there is a category, right? You try to get into whatever, the entity that started the category or the first mover in the category or the dominant person in the category. You can't get a check-in. You can't get a check-in that's like large enough, whatever. Okay, well, like, are you just gonna like say, I think this is a thing that's valuable in the category, but I couldn't get an investment early and what? Are you just gonna like stop? No, you're gonna go say like, all right, I'm gonna go find someone else who's doing this. I'm gonna go encourage someone else to do this. I'm going to go incentivize competition in the market. And so to some degree, based on however much capital is allocated to like investors from LPs, so however much capital VCs have based on the theses that they're seeing come up, you will see for any given category, at least kind of two entities playing in it, presumably, because there's going to be more capital than there is generally going to be high quality founders that are able to kind of like take that capital. And so you'll see competition in that space, right? Where the VCs will say, okay, we couldn't all get in this one round. We're going to go make a competitor to that. And we've seen that basically every single category, I think, that's like of relevance. It was like a Crom from like Celestia had a post, right? Like if there's no competition, then like there's probably no product market fit kind of thing. Like if no one's trying to compete with you, then like maybe what you're doing is not valuable.
Mm-hmm. Another question, I guess this like continues on, but like DYDX infamously had their own app chain because they couldn't control sequencing. And so do you think there's going to be a future where like they have this app chain with all these validators, but then sort of we see ZK Tech and Rollup Tech like accelerating very quickly, and sort of general provers are now sort of getting in, or general ZK VMs are now like coming out and they're like rapidly getting better? Do you think that like DYDX chain is going to then sort of ZKify, Rollupify, churn into a rollup and then just push they're not going to like dispose of their validators completely, but they're going to like push them to do sequencing?
Yeah, I mean, it's like DYDX is interesting, right? Because like DYDX was a rollup, right? Mm-hmm. V1, 2, 3, it was DYDX was like a rollup, right? And it was like an app-specific rollup, right? It wasn't just like an EVM rollup, right? And then it became an app chain because they wanted like more specifics on like sequencing, right? So I think there's a question of like, in like a matrix, right? What are the things you get out of being an app chain? What are the things you get out of being like an app rollup? One of our engineers for part of the TLDR, right, the latest in DeFi research, did some great research on sequencing rules. So like Lily Johnson, did a great post on ETH Research on sequencing rules. And, Itamar, one of our other kind of like research engineers, did a thing with kind of like a suave sequenced rollup. And there's a general idea of like rollup owned building. But I guess from our view, part of the lazy sequencing thing is it does give you like a little bit of flexibility in how your rollup chooses to kind of derive its subset of the transactions out of a shared sequencer and how it chooses to like order that. So it's not absolute in that like you can't have any like, differences in how you're like ordering or your kind of transaction throughput is done on a shared sequencer. An app chain obviously is going to give you more flexibility because like you do whatever, right? Make whatever. Do you not want to use Common BFT? Go do your own thing, right? It's infinite complexity. It's coming at like a non-trivial cost of development, right? Like, DYDX is like a very, very high quality team. It was very, very well resourced, right? I don't think everyone, I think there is a market for people who say, yeah, the app chain is going to be too much investment for me for too little gain. In DYDX themselves specifically, something I think is like worth kind of like saying out loud on like kind of like rollups is, we see this debate and noting I haven't gotten around to watching like the totally Justin Drake debate, so I don't know if this is discussed, but I think the Solana people have always kind of talked about the idea of like Solana started as like a trading chain. Like if you go listen to like 2018 Anatoly, he had a good podcast on like he was on Thinkorswim and he was like I'm getting beat on like the NASDAQ or whatever because I'm not paying to have like a data center in like New Jersey thing. He's like I'm willing to pay like $25,000 a year to like run my own like validator node to get my block production in, but like I wasn't willing to pay like the NICE rate to like get a server there. But he was willing to pay some, but he just wanted to like trade it, right? And so the point I'm trying to make is like there will always be an advantage to running a full node from a latency perspective, knowing what the state of the chain is. And that's just like an absolute sense of like, and I'll say it, this is not absolute in that theoretically you can do intra-block ZK proving, like intra-block validity proving, but validity proving, again, I am not like a math guy, right? But like my understanding is that we're in, whatever, like 3 to like 6 orders of magnitude additional computation to generate a validity proof of a given amount of execution. You could define your system as having a latency, a block period, such that you are able to only produce blocks when you have a new validity proof for it, but that will impose like a new latency requirement. Maybe in some like decade out future, we get the validity proof generation for any given state machine is faster than the block time we can't get under due to speed of light things. But right now, if you are waiting for a validity proof, you are going to have increased latency in your chain versus running a full node of the chain. And fundamentally, the economically incentivized actors, the sophisticated traders, are very clearly willing to pay like a significant amount of money for like latency, right? That's just standard in finance, right? So you'll always have a desire or a need for this like immediate finality via running a full node. We even see it in what I'd say like the pre-block production state, right? That's where like a searcher and a builder is, right? They're simulating the block before consensus has been committed over it, and they are willing to pay a very significant amount of money to essentially simulate many, many, many blocks, right? They're not just executing the one block. They're simulating like a large, knapsack problem, many blocks. So I think we'll always see that. I do think if the validity, tech kind of like pans out, and it very, very much seems like it is, we will generally trend towards that. And then there's a question of kind of like, what are the trade-offs you're going to make? I think we probably see a trade-off going towards like a smaller number of block proposers in the set, a smaller number of like full nodes acting in the set. We see things like this where, East is talking about increasing the, maximum amount of like stakes you can put into like a validator thing. That will lead directionally towards more kind of Cosmos DPoS kind of economics things of, we're already seeing that, but like via like extra protocol like Lido, Coinbase, whatever kind of like staking pools. We'll see a concentration of that because we'll just say, hey, actually, like if anyone not worried about this block in like the 1 second block latency can just go check the validity proof of it, that'll come in like whatever, 2 seconds or 5 seconds or whatever. They can just go check that. Then everyone's like, like a lot of people are just like 10 seconds is fine for me. I'll just check the validity proof. I don't need to like be like in this set of things. So that's where I think the split's going to go and directionally we're going to trend. And it's one of the reasons that like we at Astria, as we designed it, right, we bit the bullet and did like a large kind of like bottoms up design. And when we did that, we said, look, we're already making a commitment to do significant kind of ground up engineering work. That means that we can't be planning for like here and now. We have to be planning for like farther out. And that is one of the reasons why we're comfortable having a separation of execution and sequencing, right? We think the sequencing is the thing that is just going to be like limited by like a latency bandwidth, like a speed of light level, just get these damn nodes into consensus over the raw data going through the system. And then the execution and the proving of any given state machine is going to be done at the low latency threshold by some sophisticated searcher, builder, whatever, solver entity. And users are going to interact with that if they're like latency sensitive, or they're going to be the sophisticated entities running that thing, and they're going to be running their full node because they're a sophisticated actor. If you're trading with sufficient size, the cost of running a full node in a sophisticated manner is like completely trivial relative to your trading cost, right? And then everyone outside of that is going to be comfortable with like a lower, with like a higher latency, like validity proof coming kind of out of band. And so we're like, yeah, that's great. That's what we see the future is. In the interim, all these systems are kind of highly reliant on these like multi-sigs for their bridges right now. But we saw that and said, yeah, if we're going to make the bet, we're going to make the bet on that like the tech is going to come and it's going to get there. And so we're not going to design the system for what is the here and now, which we think is overly constrained in the flexibility of allowing people to kind of develop on the system, and would lead to like much larger kind of like changes having to happen to support the status quo. If the like the future, the validity proof kind of system comes along, we'd have to pull out a lot of validation logic later.
Mm-hmm. Okay, I love how you talk so fast because like I listen to my podcast at 2x speed, so when you talk so fast, I'm just like, this is great. Like, it just like instantly goes into my mind. I don't have to like wait for the next words. Another question is, if you have a shared sequencer for, let's say, like a specific network like Arbitrum and all of their sort of L3s, then can you sort of couple the execution with the shared sequencers? But if you're doing more just like sequencing any rollup, then you would have to uncouple it and do lazy sequencing?
So it's not as absolute in that, like, fundamentally, right? Like when we think about like what makes one rollup different than a different rollup, and what I mean by that is like literally like, you have two rollups that both run like Arbitrum, Orbit, whatever, Arbitrum stack, whatever, right? Mm-hmm. what is the fundamental thing that means like one rollup is like rollup A and one rollup is like rollup B, right? Like what is the thing that separates them? If they have like a shared sequencing, right? They have like this block production. Like the thing about shared sequencing is giving you the same tick, right? You have the same block timing kind of like you're in the same temporal domain as the other rollup, but fundamentally you have a different subset of state that you're reading out, right? And bridging is to some degree, right, an intersection of state. If you want to go like really in the weeds on this, ANOMA has like a huge amount of really good blog posts on heterogeneous Paxos and chimera chains and how you can like intersect these things to get like really good like synchronous composability here. But like you go read those blog posts and you be like, there's a huge complexity trade-off here, right? It just is very hard to reason about the system. It's hard to design the system, and the NOAA people are trying to do it. And like good luck to them. I think they're probably like the only team that could like have a shot at doing it. But it is like a significant complexity. So when we think about the arbitrum thing to separate the sequencing, we get the same fundamental issue, I guess, when we separate these rollups, because it's just a state growth issue, right? If I run one rollup, right, let's say that rollup is accumulating whatever, I'll be completely bad, it can be like a terabyte of state a month or whatever. That's probably like way too high, right? I run two rollups, I now have to store 2 terabytes of state a month, whatever, right? You don't really save anything by way of like, well, both of these are running like an EVM chain. And then we get into orbit things, right? Okay, well now the state machine is allowed to be like modified. Maybe that's the contract level, whatever. But fundamentally, there's still two things. And I think my view and kind of like Astria view is downstream of that is a very like, I'll say like a boxes and arrows first view of like the world. So when people say, oh, the light client needs to be like on chain, whatever, a lot of my thinking and kind of how Astria structured system is like, what software do I have to run in what configuration to get what set of trust assumptions, right? So for example, like when we run like a full node of a rollup, what we assume is a full node is, we'll say like a guess node, right? So like our like modified guess node works with their interfaces. We have any called the composer. If you want to be like a submission node, right? You want to be submitting transactions, not just like a read replica. That is like the entity that like runs the sidecar to the rollup node and submits transactions to the sequencer. It has to run a conductor. This is our read path thing. The conductor reads from both the sequencer to get soft confirmations and from Celestia to get like firm confirmations on block data, and it filters that for the rollup, and that's run as a sidecar to the rollup. Then we assume you're running a Celestia light node, but the Celestia light node is not like in the guess node. It's not like in the conductor, right? It is literally the Celestia node software, but we assume if you want to not make that trust assumption on someone else, you are just running your own light node, and then in a sidecar configuration, your conductor, when it reads from Celestia, reads from your own light node rather than someone else's RPC. For the sequencer network, right, to communicate with that, you can go use an RPC or you can run your own full node, right? And so the set of components you run, right, is fundamentally this bundle of software you run, and whether or not that is the same software is kind of like irrelevant and like maybe the wrong design. To loop that back to the Arbitrum example, right? If I want to run 2 rollups of Arbitrum, maybe they have the same shared sequencer. So maybe I'm able to share the fact that like I, as like an entity, whatever, I'm a block proposer in the shared sequencer, I'm running a full node of that shared sequencer. You only have to run one of those. You can put 2 rollups communicating with that, presuming you're not like latency constraint or like bandwidth constraint there. But you have to run 2 different full nodes of the rollup there because fundamentally they have different state databases. You don't get to save that overhead by them being both Arbitrum things, right? Like maybe, I think Georgios has done some talk about like Ref, how Ref could be used to like run multiple of these things, right? And you could say, okay, I have one thing that is executing the EVM, but I also think we're trending towards a little bit of like, increased incompatibility in the EVM components of the rollups. The rollups have like the rollup working group, which is separate from like the Ethereum EIP working group. So we're going to see the rollups try to have like their camp that is distinct from the L1 and moves at a higher velocity. But, fragmentation potentially leads to more fragmentation here. And so there's a question of like, do you save on that? But also, again, my kind of pushback on like Giorgio's thing is like, a lot of their stuff feels like that is like a theoretically like a good thing. In the practical reality of like running software at scale and like an operational capacity, generally trying to be clever is gonna bite you in the ass later. And so a lot of our thing is just saying like, okay, what's the overhead of you running like 2 ref nodes versus like running one ref thing that's sometimes gonna execute rollup A and sometimes gonna execute rollup B, and you assume that that's just gonna seamlessly work. And if like rollup A halts and like fucks up your ref thing, then it's also gonna like halt your like rollup 2 or whatever, right? Again, my view would be like, what am I actually paying to run this other node? I'm going to run, it's going to be like 4 vCPU, 16 gigs of RAM. Yeah, I am absolutely going to pay the cost of 4 more CPUs and 16 gigs of RAM at my cloud provider, because I'm not saving on the storage costs. I gotta have the state DB for both of them separate anyways. Yeah, I'm absolutely willing to pay that cost. That's like a trivial cost. So that's a lot of my view on it. And again, I'm very biased. I'm coming from like a cloud provider backend. That's where I spent like 5 years of my life, right, in like Kubernetes land. But fundamentally, like, what is a rollup? What is a blockchain really, if not a federated Kubernetes cluster? I think a lot of the rollup people or just blockchain people generally have this not invented here syndrome. And I'm like, look, we are trying to convince people to run relatively complicated networks with significant network abstractions between many modular components in a network. That's also what the cloud providers are trying to do, and they managed to all kind of like agree in a competitive manner to settle on like Kubernetes as like one open source MIT Apache 2 licensed software solution that they all share, and none of them can own it because there's like whatever, like a lot of billions of dollars, like tens, hundreds of billions of dollars, trillions of dollars kind of trying to like run on top of that. There's no reason that like crypto needs to invent its own. We're just going to do a shittier job of that.
Yeah, another question is, there's also this idea of you could have a share sequencer that like has the ideal state of 2 rollups, so they could compose I guess interoperability between them. And so you could have like an ecosystem of rollups that all use the same sequencer, and if a sequencer is at the time, just like that one sequencer is a proposer of multiple networks, and they can like they control all the I guess the proposing rights for all of the rollups. So then they could like trust themselves to I guess bridge over and interoperate and like read state for multiple rollups because they're like God at the moment. So like, what do you think about shared sequencers for composability?
So I guess I think there's like shared sequencers, lazy sequencers, they provide an opportunity to have some advantages in composability. It is not this like naive, trivial kind of like solution. I think Espresso has like an interesting design in that they're trying to kind of like, you know, Trojan horse their way a little bit into rollups that have existing sequencers, where they say you can do it as like an opt-in basis, and that's very similar to what we see with like heterogeneous Paxos and like Chimera chains in the ANOMA design, wherein you can say, okay, I am this chain and I am using this validator set, but then at some windows you will know ahead of time, doing like a look ahead window, that you will overlap with another chain's like validator set. You can even see this in Cosmos chains. The skip dies have done some experiments. If you look at Cosmos validators, very heavy overlap. And you say, I know for this temporal window they overlap, and there's like a little bit of shakiness in the completely distinct network, but you can do that, and you can say, great, I'm going to submit to this person with some ability to be enforced to some somewhat shaky level, only submit this bundle if it like goes to both of these people, and you can kind of construct a more kind of like formal and like strict system on that. The Astria view is that any given rollup that is using the Astria shared sequencer is being sequenced by the shared sequencer, and thus we have this guaranteed shared temporal window. And so really the fundamental thing is on this kind of like active bundling, and then really people like to think about this as bridging because everyone's worried about like composability things. I'll note, just to say it on the record, I think the synchronous composability problem is in like Astria's design space, and it's for these like Celestia native rollups, not really that big an issue because they run Comet BFT chains. Celestia has like a 12-second block time. If you're like, I have to do a bridge and I have to wait on like 2 Celestia blocks, you're like 25 seconds. That's kind of fine. The problem is just like Ethereum has like a 12 to 15 minute finality thing that the bridges wait for, and so you want to wait for like 2 full Ethereum finality periods, you're like 30 minutes. That's bad. But if you're just like 2 Celestia blocks, yeah, your async composability is just kind of fine. Maybe it could be better for various things, but I'll note like async composability in like a Celestia native land, dramatically better than in Ethereum land, and to some degree less important. But on the synchronous composability, the way you can kind of think about this is, I can say, you know, I know that rollup A and rollup B are both reading off of the shared sequencer, but they're read distinct streams of data. On the block production path, right, on the submission of transactions, bundles, whatever, you could say, hey, I want to submit a bundle that includes the transaction from rollup A and rollup B. This is why our native sequence action is like a bundle. It has a vec of byte, where an individual vector of bytes might be a transaction for one rollup, but the given signed transaction to the sequencer is multiple of those. It's like a vector of those, or an array of those, right? So you can have one signed transaction to sequencer be a transaction for rollup A and a transaction for rollup B, and that's fine. You can submit that as one transaction, and then that will be included in the sequencer and then kind of pulled up to rollup A and rollup B. Now the question on kind of like the synchrony and specifically like the bridging side of that that's difficult is that fundamentally like the question around bridging is kind of, people talk about like flash loans, like cross-chain flash loans, and that's really fundamentally talking about like capital efficiency, right? The thing about a flash loan is like you are, in some sense, borrowing an amount of money for an infinitesimally small amount of time, and thus the risk trends to zero, and thus the ratio of principal to like loan amount, right, can be extremely high because there's functionally no risk in the system, right? Going cross-chain, fundamentally, the chain that is receiving a bridge transaction, it's just going to have some function that's just going to be an if check on whether it's going to disperse funds to someone else, right? And what is the conditions on that like if check, right? Generally, the conditions on that if check are going to be something of the form, right, of a multi-sig signed, right? Or something around like a state root was posted, right? Like what is a light client attestation from CompEFT? It's like a fancy state root, right? With like it's a state root combined with like a multi-sig, right? Where the multi-sig is the validator set of the other chain. The presumption is that that message that multi-signature would only be signed and sent after a block is produced, and thus a state root is confirmed to verify the lock transaction corresponding to a mint transaction on the receiving side, right? Can you do these internal to like intra-block between two chains? Well, you won't have like strict finality. Again, the lazy sequencing has a limitation where you don't know if the execution went through from that transaction because you just haven't produced another block on top of that to have the finality of the data that then has the execution over it, right? How you can do this, and this gets into kind of centralized issues around bridging and lending, it's really going to end up looking very similar to something like a cross, which is these kind of like market-made, kind of like intent-based bridging, where you could have a bridge where the capital on that bridge is like owned by like a market maker or whatever, and they are able to essentially pre-simulate, right, at this builder stage of the block simulation, right? They say, well, I don't know that this block has gone through yet, right? Maybe I'm not the proposer or whatever, but I know that if this set of transactions is executed, I know this will be the resultant state before that's even been committed over, and thus I know that if that happens, I'm willing to attest to an unlock transaction in the same block, knowing that that whole bundle will go through. Now, the difficulty is there's various things where if another transaction happens before that bundle, it could invalidate the bundle, where you could have, one leg of that transaction, couldn't be done. And so you can really only do this with top of block transactions. It's really, there's a very fundamental gap between a transaction or a bundle that is the exact first thing, because that allows a simulator, right, a builder, to simulate this entire bundle and to say, I know that on state N, if I am the first transaction in block N+1, I will execute all of these things across all of these chains. If you are transaction or bundle 2, you can't get those guarantees. You have no idea what the transaction before you could possibly be, and you can't possibly secure against that. So that's our fundamental view. If you want to do this atomic interoperability thing, you're gonna need some intersection of this kind of market maker or like builder owned bridging from like a capital kind of perspective, and they're gonna have to be giving these kind of loans here, and they're gonna need to be able to participate in a top of block auction. And right now on Ethereum and like a PBS design, there's only whole block auctions. And the reason for that is that the protocol only strictly prevents equivocation on block headers as a whole. So the only thing that is in protocol, like an offense that is like notable, is if someone signed 2 block headers. There's no like sub-block level thing that there is like an equivocation rule on a protocol level. So one of the things we're looking at on Astria is creating some in-protocol mechanism to do top-of-block auctions that are not whole block auctions, where there is an in-protocol equivocation rule on that top-of-block bundle.
Mm-hmm. I think we're up for time, and honestly, I think I asked all the questions I wanted to know. This was really good. Is there anything else you want to shout out at the end to wrap it up?
No, I think this covered a lot of stuff. This has been great to kind of clear my mind here, Diego. Okay. So I really appreciate you taking the time and coming prepared with questions.
Okay, nice. Anyways, thank you so much for watching, and I'm excited for Astria to launch. Anyways, bye-bye.